This video will be on section 9.2, rational functions. We also used to do inequalities in here, but since it's not on the final and it's not really something that you would see in the next level of math, and honestly, it's like polynomial inequalities beefed up even more. It's not worth our time in this class. But if you ever need to solve a rational inequality after this class, you'll be told how to do that. All right, so the main topics in this section, one is the first thing is the definition of a rational function, which is built on what a polynomial is. And then the second thing is the domain, vertical asymptotes. This is the new part, vertical asymptotes, zeros, and intercepts of a rational function. You've actually had problems before where you figured out the domain, zero, and intercepts of a rational function. You've just never been formally introduced to a rational function. And we'll see that the vertical asymptotes are very similar to finding the domain. All right, so what a rational function is, it's a function f that is written as a fraction, and the top and bottom, the numerator and denominator, are both polynomials. And since last section we talked about what a polynomial is, I'll just write down an example before we get to the problems of what a rational function is. So something like 3 minus x plus x cubed, that's a polynomial, divided by x squared plus 1 minus 3x, which is also a polynomial, is a rational function. Okay. So if you see something like this is something that we talked about how to find the domain before, because we set the denominator equal to 0, solve that and throw the numbers away. To find the zeros of a rational function, you only set the numerator equal to 0, which we solved that. We know how to find the intercepts of any function, so we can do that as well. But the new thing here, what are the vertical asymptotes? So what we'll do first is work through the algebra of this problem, and then I'll graph this function in the calculator so you can see what the vertical asymptotes look like and that they do match up. All right, so like I mentioned, we already know how to find the domain of a rational function along with its intercepts. The new idea in this section is called a vertical asymptote. A rational function has a vertical asymptote at each value that makes the denominator 0 once the fraction is in lowest terms. So what that means is if your fraction, like on the top and bottom here, if you factor it and have any common factors, after you cancel them out. All right, so I don't know why this says number 2. Number 1 says let f of x equals x minus 2 over 8x squared minus 10x plus 3. And they were nice enough to tell us what the denominator factors to. We want to give the domain of the function in interval notation. And so for the domain, we set the denominator, and since we would have to factor it anyway, use the factored version. 2x minus 1 times 4x minus 3 equals 0. And then once we solve that, we remember what we do is we throw those numbers away. Right, so it's already factored for us, which is great. It's set equal to 0 because that's what we have to set it equal to. Right, so we set the 2x minus 1 equals 0 and the 4x minus 3 equals 0. Each factor equals 0. The one on the left, we would add 1 to get 2x equals 1, and then divide by 2 to get x equals 1/2. The one on the right, we would add 3 to each side, and then divide by 4, and we get x equals 3/4. Right. And so remember, the way to make the domain for this really you make a number line. You mark off your two numbers here. 1/2 is smaller than 3/4, so mark them off in that order. Since we're not including them, they get open circles. But we're including everything else. So everything to the left of 1/2, everything between 1/2 and 3/4, and everything to the right of 3/4. And the way we write this in interval notation, the left interval -infinity up to 1/2, it's not included, so it gets a parentheses. Union, parentheses, 1/2 to 3/4. Don't forget about the middle. Union, 3/4, and it goes right forever to infinity. And hopefully that looks familiar. We've seen this before in a couple sections earlier in the class. We've had a lot more practice with interval notation now. That is our domain. Now the vertical asymptote's the new thing. Honestly, you kind of just look at these numbers and see, do I need to use them all or not? Right, so what I mean by that is when we look at the factored version for the vertical asymptotes, can any factors be canceled? And the answer here is no. You can only cancel factor on the top and bottom if it's exactly the same. On the top we have x minus 2, and that cancels with neither of those. So this is in lowest terms. Since it is in lowest terms, that means that every number that makes the denominator 0 is where a vertical asymptote is. And we know where the denominator equals 0. It's at 1/2 and 3/4. Right, so the vertical asymptote and domain are very similar, except if you did have common terms, you still start with the domain looking at the original denominator equals 0, and then the vertical asymptote is after you cancel any common factors. But since the denominator is the same as above, it's going to be the same numbers, 1/2 and 3/4. Right, and so those are the answers. X equals 1/2 and x equals 3/4. What's important here about vertical asymptotes is you must include the x equal part because it's a vertical line. And some of the homework, they actually include it for you, so only write the numbers. Because it is a vertical line. And we'll see vertical and what are called horizontal asymptotes later in the class as well. And you'll see that we'll use x equals and y equals for those. Right, where is the y-intercept? Well, to get the y-intercept, we plug in x equals 0. Usually when you plug in x equals 0, it's easier to actually do it with the unfactored version. We got 0 minus 2 on top, and 8 times 0 squared minus 10 times 0 plus 3 on the bottom. All the places where we plugged in 0 or 0. We got -2 on the top and 3 on the bottom. And our y-intercept is coordinate pair x equals 0 and y equals -2/3. Now for the x-intercepts, and same thing for the zeros if you were asked about the zeros. When you have a fraction, you really want to set the whole thing equal to 0, but you can make a little shortcut and set the numerator equal to 0 once it's in lowest terms. Right, so it's pretty much the complete opposite thing of the vertical asymptotes. You get your fraction in lowest terms, which it already is. Vertical asymptotes where the bottom equals 0. The x-intercepts are where the top equals 0. And we've seen examples before why we can just set the top equal 0. But just think about if a fraction equals 0, that means the top is 0. The bottom can be anything else. All right, so we got x minus 2 equals 0. And we add the 2 to each side. We get x equals 2. And then for our intercept, x-intercept, the x value is 2 and the y value is 0. We only have 1, which is quite all right. 2 comma 0. All right, so like I said, what I'm going to do is go ahead and graph this in the calculator so you can see the vertical asymptotes. It doesn't matter which one you graph because the calculator doesn't need to know what it factors to. But make sure you put the numerator and denominator in their own parentheses so the calculator reads it correctly. If you want to do the factored version, you'll have like double parentheses. So we have parentheses and then parentheses 2x minus 1. Close it, open it back up, and then 4x minus 3, and close them both off. If you do the unfactored version, which is fine, you only have to have the outside parentheses. But hit zoom and 6, and it looks like that. Now, what's happening here is there's a vertical asymptote because of the way the graph shoots off. I'm going to zoom in a little bit. And what is happening here is where this graph gets really vertical. You can see the x value for here is a little more than 1/2 where I'm at is, where this line is getting vertical. We just don't include the dashed line. Now, if you're wondering, it only looks like 1, but we have 2. 1/2 and 3/4 are just very close together. So with this example, you won't necessarily see both. But know that, when I scroll over here a little bit, the x value is now bigger than 3/4. Since it's bigger than 3/4, there's actually that second one going on here. What's happening in between is it's so steep that you can't actually see it on the calculator. So this is kind of another one of those things where the calculator can help you, but it might miss out on some stuff. Or you can't necessarily see that the calculator is not showing you something. So don't expect to be able to find the vertical asymptotes just with the calculator. All right, but that's what they look like. Typically, if you're given a graph like this, they're symbolized with vertical dashed lines. And I know we've seen a problem before like this. So we've seen the vertical asymptotes before. Now this is really the only other kind of problem in this section. What is the equation of the left asymptote and the right asymptote? Well, they're x equals, because they're vertical lines, never forget that. Vertical asymptotes have equation x equals the number, just like any vertical line. The one on the left is x equals -3, and the one on the right is x equals +3 for this one. But if you just write the numbers -3 and 3, it is marked wrong. You have to make sure you write the equation. And, for this one, it does specify you should do the left one and the right one there. So just look at it and take your time. All right, but that is it for this section. Really, it's just more of a reminder on the domain and all the intercepts and stuff, but for a rational function, we have this new idea called a vertical asymptote.